Okay, so now we will discuss splitting of arrays. So the opposite of concatenation is splitting, which is implemented by the functions np.split, np.hsplit, and np.vsplit, which are first one is split, then horizontal split, then vertical split, respectively. So for each of these, we can pass a list of indices giving the split points. So x is equals to 1, 2, 3, 99, 99, 3, 2, 1. 1, 2, 3, 99, 99, 3, 2, 1. Now x1, comma x2, sorry, x1, comma x2, comma x3 is equals to np.split x, comma, in the square bracket 3, comma 5. Now we will write print x1, x2, and x3. So it gives the answer 1, 2, 3, the first block, then 99, 99, then 3, 2, 1. So notice that n split points lead to n plus 1 subarrays. The related functions np.hsplit, which is horizontal split, and np.vsplit, which is vertical split, are similar. Let's see. Grid is equals to np.arrange. Arrange, it's not arrange, it's arrange. The bracket 16. Dot reshape. Grid. This gives an answer as you can see here. Okay, so now we will write upper, lower, np dot vsplit, vertical split, grid, the square bracket 2, square bracket close. Now print upper, print lower. Now this gives an answer. This one 0, 1, 3, 4, 5, 6, 7 in the upper, and in the lower it gives like this. And now we'll write another code. Left, right is equals to dot it's split, grid, print first left, then print. This gives an answer to this. So similarly, np.dsplit will split arrays along the third axis. So now we will discuss computation on Numpy arrays. We'll make a new file. You can save this file. Checkpoint created. I will make a new file. Closing this tab. Naming the file. Computation of Numpy arrays, universal functions. Wait. Okay, so now, up until now, we have been discussing some of the basic nuts and bolts of Numpy. In the next few lectures and sections, we will dive into the reasons that Numpy is so important in the Python data science world. Namely, it provides an easy and flexible interface to optimized computation with arrays of data. Computation on Numpy arrays can be very fast or it can be very slow. The key to making it fast is to use vectorized operations generally implemented through Numpy's universal functions, ufuncs. So here you can see, you can read from here. Okay, so now this lecture and upcoming lectures will motivate the need for Numpy's ufuncs, which can be used to make repeated calculations on array elements much more efficient. It then introduces many of the most common and useful arithmetic ufuncs available in the Numpy package. Let's start with the slowness of loops. Okay, so Python's default implementation known as CPython does some operations very slowly. This is in part due to the dynamic interpreted nature of the language, the fact that types are flexible so that sequences of operations cannot be compiled down to efficient machine code, as in languages like C and Fortran. So recently there have been various attempts to address this weakness. Well-known examples are the PyPy project, a just-in-time compiled implementation of Python, the Cython project starting with C, which converts Python code to compilable C code, and the Numba project, NUMBA project, which converts snippets of Python code to fast LLVM bytecode. Each of these has its strengths and weaknesses, but it's safe to say that none of the three approaches has yet surpassed the reach and popularity of the standard CPython engine. So the relative sluggishness of Python generally manifests itself in situations where many small operations are being repeated. For instance, looping over arrays to operate at each element. For example, imagine we have an array of values and we'd like to compute the reciprocal of each. A straightforward approach might look like this. Import numpy as np np.random.seed df compute reciprocals sorry about that. Output is equals to np.empty len values for I in range len output in the square bracket I is equals to 1.0 divided with slash values I. Return output values is equals to np.random dot rand int the bracket 1 10 size is equals to 5. Now compute reciprocals. I don't know why it's giving it an error. Let's look at that. The 10th. mistakenly put double I. Now we have another error. Spelling errors. This gives an answer to this one. Okay, so array is going to be here.